Course Compass, if you click on the Assignments button, about the fourth or fifth item down, and I'm not real sure about that, you will find an item or a folder that's labeled Supplemental Material from your instructor, or maybe it says Very Important Material from your instructor. Within that folder, you will find chapters, and if you look for the appropriate chapter that you're studying, if it's Introductory Algebra, it's probably Chapter 6. If it's Intermediate Algebra, it's probably Chapter 5. Open the folders there and look at the material that I've provided, the supplemental material that I've provided for simplifying, multiplying, dividing, adding and subtracting rational expressions, and solving rational equations. You may find that is just as helpful as these videos. We're going to go on to the first of 5 operations, if you will, and actually simplifying is just a reducing process. Right now I'm going to share with you about 5 examples. We've already done this kind of problem, 4x squared over 20x. We've simplified that already. Please just remember, this is just a monomial divided by a monomial. You just need to remove common factors. Oh, I'm sorry. A 4 goes into here once, and a 4 goes into here 5 times. And finally, x squared over x to the first power is equal to x. So x in the numerator, 5 in the denominator. If you wanted, you could put a 1. You could just write it as x over 5. You could even write it as 1/5 x. All of those represent the same thing. We've reduced the x's by subtracting their exponents, and 4 divided by 20 is 1/5, or reduces. Another example. When you simplify rational expressions, and this is something that I've put in those handouts that I was just talking about under that important additional information. As a matter of fact, simplifying, multiplying, and dividing requires that you factor everything first. In this case, this numerator can be factored. I can remove the greatest common factor, in this case a 2, out of that numerator. And when I do, I'll need a 9a minus 1 in parentheses. Just check that out. 2 times 9a is 18a, and 2 times a minus 1 is a minus 2, over the denominator of 22. And what I'm going to do now is I'm going to reduce these factors, because they truly are factors. A 2 goes into here once, and a 2 goes into here 11 times. And so what I'm left with, when having simplified this problem, is in the numerator 9a minus 1, and in the denominator 11. When looking at a problem like this, people often think that they can just reduce those 8x's and reduce those 16's, and maybe have something like 1 minus 1, possibly. You cannot simplify rational expressions, nor can you multiply or divide rational expressions until you've factored everything first. These are not factors right now, they are terms. This is a binomial. This is a binomial as well. You must take the greatest common factor out, in this case the 8, out of the numerator, and when you do that you'll need an x plus 2. And in the denominator's case, you also need to factor out an 8, and when you do, you'll have an x minus 2, and I can remove those common factors. That's equal to 1, the 8 over 8. I won't write it down. My answer to this problem, its reduced form, is x plus 2 over x minus 2. You cannot reduce this. These are not factors. It goes back to the concept of multiplying with fractions. When you take 2/3 and multiply it by 5/6, we can reduce or remove a common factor here of 2 in each one of these, because we are multiplying, and we get 5 over 9. I can only do this when I have a multiplication symbol here. I can only remove those factors. I can't do this because this has got a plus sign here. They are not factors. As a matter of fact, this is x plus 1 times x plus 2 times 1, and this is x minus 2 times 1. There are no common factors other than the 1. I must leave that alone. Continuing the simplifying process, I'm going to take the greatest common factor out of these two terms. That's a 2 and a y. And when I take that out, I'll need a 2y minus 1 here. And in the denominator, I have a common factor of a 5 and a y. And I'll remove that, and I will need a y minus 1 here. The only thing that I can reduce out of these two terms, or two expressions, is this y, because there are multiplication symbols. I can take the y out of each of those. That's all that can be reduced. So what I'm left with is 2 times 2y minus 1 in the numerator, and 5 times y minus 1 in the denominator. Again, I'm still simplifying rational expressions, and you need to remember, again, the steps are written on the top of those review sheets that I put in Course Compass. You need to remember that you must factor everything first. Unlike the last few problems that I've been doing, these do not have greatest common factors. These are trinomials in both the numerator and the denominator. And I need to factor these trinomials, which are the nice kinds of trinomials, into the product of two binomials. Let's look at the numerator first. I've got a 1y squared in that numerator, so I'm going to put a y in the front of each of these binomials. Now I'm looking for two numbers whose product is a -9. That means one's got to be positive, one's got to be negative. And those two numbers have to add to be 8. So there's no way 3 and 3 will work. It looks as though I'm going to have to use a +9 and a -1. Their product is a -9. They do add to be a +8. Downstairs, I'm going to put a y in the front of each of these binomials, and I'm now looking for two numbers whose product is a +4. They're going to both have to be minus, because I want them to add up to be a -5. It doesn't look as though 2 and 2 will work here, because they won't add to be 5. It looks as though I'm going to have to use a 4 and a 1 here, because they will add to be a -5. The one thing you want to watch for is once you've factored a numerator, you're going to probably find something that's common in the denominator to that numerator. In this particular case, I do have factors now that I can reduce, the y-1 on top and the y-1 on the bottom, leaving me with the reduced form of this expression of y + 9 over y-4. And I'm spending a lot of time on doing quite a few of these problems because multiplication and division is almost exactly the same. You just end up with two sets of fractions. Here I just have a rational expression. But the process continues. I have to factor. This happens to be two terms with a minus sign in between. Please recognize that as the difference of squares. That's an easy one to factor. I'll put a t in the front of each of these because their product is t squared. The square root of 25 is 5. I'll put in the back of each of these a plus sign in one, a minus sign in the other, because their product has to be a minus 25. And remember that the inner and the outer terms will add to be nothing. There is no t term here. The denominator is a trinomial with a 1 in front of the t squared term. So I need to put t's in the front of each of these. I'm now looking for two numbers whose product is a negative 20. That means one is positive, one is negative. And they have to add to be this understood 1 that's in front of t. So I'm going to have to use a 5 and a 4. As a matter of fact, it looks like the 5 is going to have to be positive. The 4 will be negative because I want those to add to be a positive 1. Finally, once I've done that, I am looking for common factors that I can reduce. Again, it's called simplifying or reducing. And I'll remove those, and I'm left with t minus 5 in the numerator over t minus 4 in the denominator. Please do not cross those out. Those are not factors. It reads t minus 5. It doesn't read t times anything. That's when you can reduce. It's when you've got multiplication. Fairly simple example. Again, got to factor everything first. In this case, I see in the numerator a common factor of 4. I'm going to get that out. And when I do, I'll have an x plus 8. That's done. I can't do anything more with that. And in the denominator, I have a trinomial where I'm going to factor that into the product of two binomials, an x in the front of each one. I need two numbers whose product is 8 and sum is 9. They both have to be positive, and looks as though they'll have to be 8 and 1. Again, I'm choosing some fairly simple problems in terms of factoring. You'll get into problems that have coefficients in front of the x squared term. It's just the same process. You are looking to remove common factors. Those are binomial factors that I can remove, and I'm left with 4 over x plus 1. This is a very basic concept that people often struggle with. 5 minus x and x minus 5 are not exactly the same. Even if I put them in parentheses and look at those as two binomials, subtraction is not a commutative process, so you cannot just cross those off. What I'd like to suggest is that you consider factoring out a negative 1 out of either the denominator or the numerator. I'm going to go with the numerator in this case. When I take a negative 1 out of this expression, I'm going to need a minus 5 here, because a negative 1 times a negative 5 is that positive 5. I'm going to need a positive x here, because a negative 1 times a positive x is that minus x. And then I'm going to put it over this common denominator of x minus 5. Please notice that these, while not looking exactly the same, are, this x is positive, so is this one. This 5 is negative, this is basically plus a negative 5. I'll rewrite it one more time. You have in the numerator a negative 1 times x minus 5, and in the denominator, x minus 5. What we do, therefore, is cross these common binomials off, and this original expression is equal to a negative 1. From here on out, whenever I see this, when I see opposites, if you will, the 5 here is positive, the 5 here is minus. the x here is minus, the x here is plus. I just go ahead and cross those off and replace them with a negative 1. The last problem I'd like to share with you with regards to simplifying rational expressions. Again, like we've said before, you need to factor everything first. So in this numerator, I can factor that into the sum and difference of like terms. I'll need a plus 1 in one of these, a minus 1 in the other, doesn't matter which order. And then downstairs, I'm going to have 1 minus x. I'm going to notice that this binomial and this binomial are opposites. The x here is positive, the x here is a minus x, a minus 1 here, and a plus 1 here. I never go through the work after I've done it once before. I'll remove those, and I'll remind myself that I am going to have to replace that piece that I'm simplifying here. That's not equal to 1, it's equal to a negative 1. Your answer for this, and Course Compass might accept this in one of two ways, and if it marks you wrong, you need to write me an email. Your answer for this would be, I like to put my negative 1 out in front, times sx plus 1, or another way to write this is to distribute the negative 1, so the book might do this as well. A negative 1 times x is a negative x, and a negative 1 times a positive 1 is a minus 1. These two answers are correct. If you are marked wrong in a test-taking situation, remember to email me and I'll mark it correct.